Hey, it's Tony from Adafruit, back with more MicroPython action. So a little bit of a break in the past few weeks. Had all kinds of fun stuff going on, like World Maker Faire out in New York, and just last week, the Open Hardware Summit in Portland. So now hopefully some free time to get back to MicroPython stuff. And in this video, I wanted to look at how to use the SSD1306 OLED display with MicroPython on the ESP8266. So a lot of buzzwords, but I'll talk a little bit about what it is. Basically, it's a little OLED display, organic LED, so really nice, bright, kind of high contrast displays that come in a convenient little feather form factor that I'll show more about. And you might wonder why I have these band-aids on my face. I had a little bit of an incident during a hike yesterday, so bruised my pride more than my skin, so nothing major, but hey, it happens. So let's just get started. I'll dive into what we're going to look at, and this will probably be a little bit of a quick stream. Let's see. So we'll go to the main view here. And the thing that I have up here in the upper right-hand corner, this is the ESP8266 Feather Huzzah board. And so that has the ESP8266 little Wi-Fi microcontroller module in the Feather form factor. And then this thing above it is the SSD1306 OLED Feather Wing. And so I'll show you the two products here. Basically, this is the Feather Huzzah board right here. I've used this in a bunch of the ESP8266 MicroPython videos. Really nice little module, runs the MicroPython super well. And then this is the OLED module, and I'll put links to both of these in the description below when this goes up on YouTube. And so this is a Feather Wing, and so the idea is that it's really easy. You can see there are little headers that are soldered onto here, and you can just slide this right into your board, push it down, and you're connected and ready to go. Kind of like an Arduino Shield, but smaller form factor and specific for the Feather boards here. And you don't have to use these, you don't have to use the feathers. You could use any SSD1306 OLED. This just makes it a little more convenient. You know, if you're using your own OLED, like a breakout board, you might need to wire it up, you know, using like a breadboard, things like that. So the code will still be the same or pretty similar, but this just makes it really nice and easy. And it's cool, the form factor is nice and small. So you've got like a tiny little device here, you know, you put this on, and you've got a little display that you can use. It's 128 pixels across by 32 pixels down, so a decent amount of space here. You can have like a couple rows of text on here. So like if you're displaying maybe like a sensor reading or something like that, this would work really well for that. So let's see. Oh, someone's asking, is it video? No, this is live. So this is totally live. It's live from the Pacific Northwest, MicroPython and electronics. So, okay, so let's get started then. And like I said, I'll put links to these products if you're curious. When this goes up on YouTube, you can check in the Adafruit shop also for these things. And what I wanted to do is show how to use this little OLED Feather Wing with MicroPython on the ESP8266. And it's a little small process you have to do to use this. So the MicroPython firmware for the ESP8266 by default doesn't come with a driver for this OLED built in. And that's mostly just a memory saving thing because all of the ESP modules have different size flash memories, so it's hard to put every driver into the MicroPython firmware because it might not fit on some of the smaller modules. So you kind of have to pick and choose what drivers you want, and then you have to build a custom firmware, which sounds a little scary, but it's really not that hard, and I've done this in a bunch of videos. I actually have a whole guide on it right here that you can check out, and I'll put a link to this guide and all the guides and things that I mentioned in the description when this goes up on YouTube. But there's a guide right here where I talk about how to compile your own firmware for MicroPython ESP8266. And it uses a little virtual machine based on Vagrant. It's a real popular thing that a lot of people use. It makes it easier to have a cross-platform tool chain, so you don't have to figure out how to set up like an ESP8266 tool chain on Windows versus Mac OS X. Just run it in a virtual machine. It's a lot easier. The performance overhead really doesn't matter these days for it. So definitely check out this guide. I'm gonna start assuming that you followed this guide and you have this virtual machine set up and you're ready to go to compile firmware for MicroPython. So we'll just get started with that. And I'm actually inside of my virtual machine right here in this terminal. And so you can actually see I'm inside of the ESP8266 directory in the MicroPython source. So this is, you know, basically where you would go to build the firmware, and the guide mentions exactly how to do this. Now the interesting thing is the driver that we need, it's not in the ESP8266 code by default. It's actually in the MicroPython source code. There's a drivers directory right here. So if you jump into that, Then there's a whole little set of drivers. So there's stuff like the DHT temperature sensor, which maybe we'll look at in a future video. Some of the displays, there's some drivers built in here, and that's what we actually want to look at. So if we go into the display directory, well, for now, I guess there's just one display, the SSD1306 OLED display. So this is what we want for our MicroPython ESP8266 firmware. So we need to take this driver and build it into the firmware, because if you go back to the ESP8266 firmware in the ESP8266 directory inside of here, and remember in some of the previous videos and guides I mentioned, there are two different folders. There's the scripts folder. So in the scripts folder, this has modules that are included in the MicroPython firmware, but they're not frozen. So there's this concept between a frozen module where it's like packed into the RAM or the ROM of the firmware, and it's like super efficient bytecode, versus the scripts are just storing literally the Python source code in flash memory. So it's a little more efficient. It's basically a way to build a Python script into a custom MicroPython firmware. And so that's what we want to do. We want to take that SSD1306.py file, which is the driver for this little OLED display, and copy it into this scripts directory in the ESP8266 firmware. And then that way, when we build the firmware, it's going to grab that source code and include it in the MicroPython firmware, so that if we flash our device with that firmware, that module will be included and we can actually import it and start using that code. In the future, there might be other ways to do this. So, and again, like MicroPython's still a little young and things are changing pretty rapidly, but there is a concept of these MPY files where it's bytecode that's been generated ahead of time. And on some of the boards, like the Pi board, and I believe probably the YPi, maybe not, but unfortunately not the ESP8266, you can take these MPY files and actually copy them to the file system on the MicroPython board and import them directly. So I have a feeling in the near future the ESP port will probably support that. And then this might get a little bit easier where you can just probably grab a .mpy file that someone's compiled ahead of time and put that on your file system and import it directly. And that's kind of how we're thinking we might distribute a lot of the Adafruit drivers in the future. But for now, you kind of have to do this manually with the ESP firmware. So this is just still good to go through the process and you kind of see how to add stuff to your own firmware build here. So, okay, so I need to copy that driver.py file into this scripts directory. So let's just run a copy command, and it's a couple levels up. It's in that drivers directory, display, and then the SSD1306.py. So I'll copy that into the scripts directory. Now if I look at the files in here, you can see I have that SSD1306.py. And you can look at the source code for this. So this is just directly from the MicroPython source code on GitHub right now. And it's just pure Python source code. It's pretty cool how, again, like MicroPython is real Python. And so there's a class in here that defines the SSD1306 OLED. You can see some of the parameters that it takes for the initializer here and how it works. And it's really just interacting using the I2C interface. So there are two classes here. There's an SSD1306 I2C class and an SSD1306 SPY class. So in this video, I'm just going to use the I2C class because that's how this little feather OLED wing is set up. It uses the I2C interface. Some of the SSD1306 boards use SPY, so just be aware you might need to change the class that you're using slightly if you're using like a breakout that uses the SPY interface. But the source code is really simple, and again, it's all kind of high-level Python, so you can look at it and understand how it works. And this is also a good model if you're writing your own driver to talk to an I2C device. You can start looking at how they've done it for some of these other devices in the MicroPython source and get an idea. At a really low level, it's just using some of these I2C writes and reads. So like it has a write command that this class defines, and then the subclasses like the I2C class fills in what it means to write that command using the I2C interface. So you can see it uses this I2C class and the write2 class and stuff like that for this. So that's what we're going to use here. And also a special note, this might not work on the Pi board right now because unfortunately the Pi board has a slightly different interface for the I2C classes. It uses recv and send instead of write to and read from. So I've mentioned this in the guide and video that I did on I2C with the Pi board. I think over time they're going to unify the API, but again, there are little differences right now in MicroPython. So that's kind of why I think in this video, this is really more specific to the ESP8266 and getting this OLED to work. In theory, it should work on the Pi board, but you're probably going to have to go in and change some of these function names. In the future, hopefully this will go away once some of the later firmwares come out, and maybe some of that unification happens to simplify the hardware API across all the boards. So okay, so back to our VM, we copied the SSD1306.py into the scripts directory. So that's all we need to do, and now we need to build the firmware. So I'll go back up to the ESP8266 folder, and then to build the firmware, first, usually you'd want to run the clean command. This will just delete any previous binaries. It helps to make sure that you get a good build that includes everything that you've changed, like if you've added new scripts. And then just run the make command. And so this is going to go through and make the source code or the firmware for the ESP8266 MicroPython port. And it's pretty quick. It'll just take a minute here. So you can see it's going through, it's compiling all the source code for this. And then in a second here, it'll pop out the firmware. And then once this is done, we're going to have to flash this firmware to our little ESP8266 module right here. So we'll give this a second, and I'll show you how to do that. Now, I haven't set up this virtual machine yet, unfortunately, to allow you to flash the firmware from inside of it. If you saw my last video from a couple weeks ago, we were actually playing with the SAMD21 board, and I've set up a Vagrant virtual machine for that you can compile MicroPython firmware with. But I went the extra mile with that one, and it does USB pass-through, and you can actually flash the board directly from it. So maybe in the future I might come back and see if I can do that for the ESP board. So okay, so the firmware built. It's important that you don't see an error here. Like, you actually want to make sure that it ends, and you can see like it built this firmware.elf file, so that has the file, and the actual firmware file we want is this firmware combine.bin file. And what I need to do is I need to copy this out of my Vagrant virtual machine. So if I copy from the build directory the firmware combined.bin file, and if I put this in the /Vagrant folder, this will copy it into the folder that Vagrant syncs between the virtual machine and the PC that's running the virtual machine. So I just do this, and now if I go outside of my virtual machine, so over here I'm in a directory, I'm in the same directory as the Vagrant file for this virtual machine. And you can notice in here, there's the firmware combine.bin file, and if I actually look at, all the details of this file, it was just modified a second ago. So basically Vagrant copied the file out of the virtual machine into my real machine here. And so now on my real machine, I can use the esptool.py to flash the firmware onto this board. So what I'm going to do, I'm going to connect my Feather, Huzzah, or the ESP8266 over here. And now I'm going to erase the flash memory on the board. Just in general, when you're loading MicroPython firmware, it's smart to erase the flash memory on the ESP8266 because some state is stored in there, like I think the web REPL and stuff like that. So usually you want to start from a clean slate. And so the command for that is you first have to give it the port. And so for my device, it's this Scilab's USB to UART. And go back to the guides on MicroPython. I have a whole guide on how to load MicroPython onto a board where I talk about, like, it shows up as a serial port. You might need to install drivers. On Mac OS X, you do have to install a driver, the Scilab's driver, and I believe Windows also needs a driver. I don't think Linux needs a driver. It's been a while, but check the guide, and I go through all of that. And then, okay, the command I want to run is erase_flash. So this will connect and erase the flash memory on the board. So you can see it's kind of lighting up a little bit right here as it's doing it. And okay, so it just erased the flash memory. And now I actually need to burn the new firmware onto the board. So for that, there's another esptool.py command. And again, I have to give the port, so it's the Scilab's USB to UART. And then for this, I'm going to go back to the guide that I did on this, and then in the flash firmware page, because I always forget exactly what it is. There's a certain baud rate you can use. So here's the command that you want to use. So I want this baud rate, and then the write flash command, and then the flash size. This 0 is where it starts writing the, excuse me, the flash memory. So this basically says start at the beginning of flash memory, and then the firmware combine.bin is the file that we're actually going to burn. So I'm just going to paste all of these parameters in here. So again, you can see esptool.py, give it the port for the board, give it the baud rate, so pretty fast baud rate, the write flash command, then the size of the flash memory, scroll back down, the offset where it's going to start, which is always going to be 0, and then the actual file, that firmware combine.bin, which again, remember, we copied that out of the Vagrant VM. So it's in this directory right here. So I'll run this, and it should connect here in a second. And it goes through and does this little flashing thing. So it's just writing the memory of the flash memory of the board with the MicroPython firmware. So you can see like the blue light kind of flashes right here on this module. So we'll give this a second. It's just about done. And okay, so we just finished there. And then you do want to reset the board. So I'm just going to press the reset here before you can connect. And then it's always smart after you flash the firmware, connect to the board. So I'm going to use the screen command, or if you're on Windows, you'd use like the putty, open the serial terminal basically at 115200 baud. And just check that you can get the MicroPython REPL, the Python prompt. So let's open up the Scilabs at 115200 baud. And so I connect, and then I press enter, and there's the Python prompt. And so say, hey, hello world. So cool, so we've got our MicroPython firmware loaded. And again, remember, this is the custom firmware that we added that SSD1306 module to. And if we want to test that that module is there, if I go back to the source code, so this was called SSD1306.py, I should be able to run import SSD1306. And hey, look at that, that succeeds. So the reason this succeeds is because we put in that scripts directory this SSD1306.py, and then when you run the import command, it's going to look to see where it can import, where it can find that source code for that SSD1306 module. And Python has a whole chain of things that it looks at. So it looks for like a module, like a package that's called SSD1306. If it doesn't see that, it looks for a file with the SSD1306.py name, and if it finds that, like it found here, then it will import that as the module here. And so if you're curious, you can use the dir command to see like what's inside of this package or inside of this module. And so this shows you there's like a bunch of constants, which if you're looking at the source code, you can see these are like the global constants that are defined in here. And then the, excuse me, the classes are also in here. So you can see like here is the SSD1306 class, and then here's like the SSD1306 I2C class. Now, unfortunately, there's no documentation on this SSD1306 module. So this video is kind of the documentation right now. I'm hoping to do a guide on this in the near future though, so where I'll just kind of write down what I'm showing in this video. But it's not too hard to look at the source code for this and to see what you can do. So really just look at the functions that are available on this class, and I'll run through this in the video in a second here. But it's pretty simple. So you can put pixels, you can fill the screen, you can actually write text, and then update and display things on the display. So there's not a lot of commands to learn yet. It's a little bit simple, but this is just one way that I wanted to show though, using this dir command, which I've shown in a bunch of videos. This is a good way to look at like what's inside of a module, so you can see at least like what are the functions or the classes or the variables inside of there. So in general, maybe try dir, but sometimes you have to go to the source to see what's how to use something here. Okay, so to use this module, again, remember I'm going to use the I2C interface. So I need to first create an I2C interface for the ESP8266. And I guess I might as well just plug in the module while I've got it going here. So I'm just going to take my little SSD display and just push it right down onto the board here. And I'll see if I can keep this cable from kind of flipping over the board here. It's a little bit, let's see. There we go. I think this will hopefully hold it. Yeah, there we go. That's sort of close. I should have set, there we go. Okay, that's perfect. Not going to move it now. Oh, it's slowly moving. We'll see. We'll make this work. Okay, so let's make an I2C interface, because if you look at the definition for this SSD1306 I2C class right here, you can see the initializer, and if you're not familiar with Python classes, this init function, think of this as the constructor. So when you create an instance of an object, this initializer is called, and then these are the parameters that it takes. And so there are a couple required parameters. There's a width and a height in pixels, because these SSD1306 displays, they're different sizes that you can have. So this needs to know what size display you have. Then it needs to take an instance of this I2C class. And so it's not super obvious from here what it wants, but I'll show you. Basically, you need to create an I2C bus object, which you tell the class, and then the class will use that to talk to the board. So I actually did a whole guide and video on this, this MicroPython hardware I2C devices guide. So check this out. This will give you some background on using I2C devices with MicroPython. And so I show you how to use this with the ESP8266. I was using a temperature sensor, if I remember correctly. But for this OLED, it's very similar. So I just need to create this I2C interface like this. And for the ESP8266, it has a software I2C interface. So it bit bangs I2C, which works. Like, it's not super fast, but it's good enough to, you know, talk to this OLED display. So this is what I want to do. Basically, I'm going to create an I2C interface, and it's going to use pin 5 as the clock and pin 4 as the data line for this. So let's just do this. We'll import the machine module. We'll create an I2C bus, and this is a machine.I2C interface. Oops, I2C uppercase. And then I tell it the clock pin is 5, and the data pin is 4. And for these feather wings, that's the I2C interface that they use for the SSD1306 and the ESP8266 board. So the cool thing about the feathers, there's actually a dedicated SCL and SDA line. So all of these wings that snap on, if they're an I2C device, they're just automatically going to use those pins. So if you're using the wings like this, use pin 5 and 4 like I show here. If you're wiring things up yourself, you might need to see, like if you're using different pins for the clock or the data line, you probably have to change which ones that you use here. Okay, so we'll create this. And then a quick little thing, a good test just to make sure that your device is there and it's powered up and it's visible. Run the scan command. So I mentioned this in the I2C guide. This will check to see what devices are on the I2C bus. And so this returns back in decimal the address of any device that it found. So it found a device with address 60 in decimal. And this is good because if you look at the SSD1306 class right here, it takes in an address, an I2C address, but it defaults it to OX3C in decimal. But if I wanted to see what is the value of that in, or OX3C in hex, if I want to see the value of that in decimal, I can actually use Python to do that. So you don't even need a calculator, just create an int object. So that's 60, and that's good. So that's telling me that there's a device on the I2C bus with I2C address 60 in decimal, and that's the same as what this code expects, because each I2C device has its own address assigned to it, and sometimes you can change them, but for these SSD1306 displays, at least in this case, the default is 60. And so it's good. I see a device with the address of 60, so that's telling me that this board is, or this display is powered up at least enough so that it can respond and see that messages are being sent to it on the I2C bus. If you don't see this, and you're using like the feather wing like this, double check your soldering, make sure that there are good connections here on the header, and then maybe try testing it with the Arduino IDE. So like load up our Arduino library for this device, make sure that you can see this thing working in isolation before you get too deep into like trying to use it with MicroPython here. Okay, cool. So I have the I2C interface, and now to create an instance of this, I'm going to create an instance of the SSD1306 I2C class. So to do that, we'll say, how about OLED equals the SSD1306 module that we imported dot SSD1306 underscore I2C. So this is going to create an instance of this class, the SSD1306 I2C class, and then I need to pass in the parameters from the initializer, so the width and the height. And for this OLED, it's 128 pixels wide by 32 pixels tall. And then I need to pass in the I2C bus instance. So that's the I2C object that I created ahead of time right here. And that's all I need to pass in. So by default, the I2C address is going to use the default, and then this external voltage is also going to be the default, which you want false for this board. So we're just going to keep the defaults here, and we'll create this object. Okay, cool. So that worked. And then by default, nothing really happens. Like when you create an instance of this class, it's not going to write anything onto the display. So now we're ready to use this class. And so you might be a little confused, like if you look at this class, the SSD1306 I2C class, there aren't any functions on here. But remember, this thing inherits from the SSD1306 class up above here. And so it actually gets all of the functions that are defined in this parent class. And so there's some useful ones in here. There's basically this show function where when you call this, it's going to write out its internal buffer of graphic data. So it reserves a little bit of memory, basically that 128 by 32 pixels of memory it's stored, or of graphic data on the OLED. It's going to store in memory a representation of that so that you can like change the pixels on there, you can write text to it, you can modify that buffer, and then when you want to actually display it on the hardware, you call this show command, and that's going to write the buffer out. It's a real common thing with a lot of displays where you have to keep in memory a buffer, and then you send that buffer out when you want to display it, so that you don't kind of see, as you're writing to the display, like this pixel turns on, then that pixel turns on. You do all that in memory, and then you push it out to the display at once. But you'll see there are a few functions down here. So there's a fill function where you can pass in a color. And remember, these are monochrome displays. So the color is basically 0 or 1. If it's 0, it's going to be dark like this. And then if it's 1, it's going to be turned on. So like a bright white color for this. So you don't have like multiple colors with this OLED. There's a pixel command. So this just takes in the X and Y position and then which color, so 0 or 1, on or off. And then a scroll command, which will actually move the frame buffer around, and then a text command where you can actually write a line of text on here just using a little font that they have built in. I think it's an 8x8 pixel font, something like that. So it's got basics. There's unfortunately like no line drawing commands or things like that. So again, it's a little bit early days, but you could build like a line drawing function, using these pixel functions. And if you're really curious, look at the GFX library, the Arduino GFX library that we publish. That's an Arduino library that Phil B created, really super useful library. It has all these primitives like how to draw a line. There's actually a pretty sophisticated algorithm for that, Bressingham's algorithm, if I remember correctly, to draw like a line, maybe a diagonal line or straight line, how to draw like circles and things like that. So you could probably take that code and convert it into Python without too much work. And instead of using like the pixel commands in the GFX library, you'd use the MicroPython pixel command here for this. So, something to think about for the future. Oops, I just went back a page there. Okay, so let me show the basic usage. Let's just turn on a pixel. So if I go and if I run the OLED.pixel, oh, and if you're curious too, you can use that dir command. So if I use this on the OLED object, this is going to show all the functions on this object. And you can actually run help. This is another one I've shown before. And so this shows, hey, there are these functions. Oh, this is funny. That's actually kind of funny. The help command here, it's showing help on the SSD1306 object, but it doesn't realize that this object inherits a bunch of other functions, versus the dir command here seems to realize that. Oh no, it actually doesn't realize that. Huh. Well, I don't know if that's a bug or not, but maybe it's not showing you everything in here. So interesting. I didn't try this before, so maybe that's not as useful. Unfortunately, you have to go back to the source code to see how this works. But I'll show in this video. This is the basic usage. So the pixel command, this takes in the X and Y position. So let's just say like about 0, 0. So this will be the origin, and then the color. So the color is 0 or 1, and if it's 1, it'll be like turned on like a white pixel. So I run this. And you don't see anything change, because again, remember, that's just changing the frame buffer in memory. But if I run the show command, if I remember correctly, yeah, the show command is what we want. Now we should hopefully see a pixel turn on. And it's really hard to see, but there's a tiny little white pixel right here. You can probably see that in the video. So we turned on that pixel at position 1, 1. Let's just double check though. Let's try at position 127, 31. So this should be the complete opposite corner over here. So I'll turn that pixel on, and then let's run the show command. And again, remember, this other pixel should stay on because my frame buffer, it's going to remember all the pixels I turned on. So this 0, 0 pixel is still turned on until I turn it off, or if I clear the buffer, it'll still be on there. So now I run the show command, and yeah, now you can see there's a pixel in the kind of lower right and upper right corner. So that just shows, that's basically all of the pixels on the screen, or at least I'm showing, the minimum and the maximum one on here. So, okay, that's basic pixel usage. The fill command is kind of useful. So you can use the fill command. This just sets every pixel. So if I want to like make this completely white, I can say OLED.fill1 and then OLED.show. And hey, look at that, totally white screen. So that's kind of cool. And then if I want to clear the screen, like a simple little one-liner would be fill with 0 and then show, and it's all clear. So this is good, like if you want to animate something, you probably want to clear the screen and then put your pixels out there and then call the show command. And then the next really useful command is the text command. So this will write a string of text. So let's just say hello world, And you have to give it a position, the X and Y position. So this is kind of the upper left-hand corner of where it's going to start writing this text. Let's just say 0, 0. So this will be the origin again. And then the color, you can specify 1. It actually defaults to it. You can see right here. So by default, the color is going to be 1. Like basically you're writing white text on a black background. So I don't even need to specify this. Okay, so I do that, and then OLED.show. And hey, look at that. And it's upside down, so we'll see if we can turn this around a little bit. And this is the cable here is really not going to like this, but there we go. If I hold that down, potentially, I need like some clamps here to hold this down. I think almost there. Yeah, there we go. That's close enough. That's good enough. These battery charger comes in handy. It's not a super heavy thing, but something to hold it. Okay, cool. So you can get text, and that's pretty easy. And let's put like another line of text on here. So I believe the text is 8 pixels tall, if I remember correctly. Maybe it's like 10. Let's try it. So remember, this is the X position and then the Y position. So if I keep X position 0, that's going to be the farthest left part of the screen here, because this is position 0, and then all the way on the right here is position 127, because it's 128 pixels long, and 0 counts as 1, so 0 to 127. So and then the Y position start at 0 at the top, and then 31 at the bottom. So let's try like position 10. So I'm going to write, and instead of hello world, we'll say, let's say MicroPython down here. So this will write that line of text. And this is cool, because remember, this is Python, so you can use string formatters. Like, let's say you read a sensor reading, and you wanted to, like, put your sensor reading in here. I can put in, and like, I don't know, let's say like 0.2f, something like this. So like take a floating point value, and I just want to show like up to 2 decimal points for it. Use format, and then let's put in like, I don't know, how about 57.2578, something like that. So that's just gonna, use this value, and it should nicely format it as like a decimal with a decimal value with 2 digits after the decimal point. So okay, so let's do that, and then let's do OLED.show. And hey, look at that. Okay, so it kind of scrolls off a little bit, but MicroPython 57 dot. Let's clear the screen and see if I can actually show that full line of text. So let's do our text. And again, remember, press up and you get, in MicroPython, the previous command. It stores, I think, up to like 5 commands in memory, so I don't need to like retype this command. So okay, so let's just try, let's pretend like we were, writing a sensor reading here. So we'll say like, I don't know, how about humidity, something like that. And then we'll print out that value. And now if I do OLED.show, then hey, yeah, humidity 57.28 right there. So that's pretty cool. It's super easy, like one line of text. You don't have to mess with like printf and all the fun that you might have in the Arduino world. So it's just Python. It works just like normal Python, and it does look like about 10 pixels will offset the text. So like if I want to put let's put like temperature at the top. We'll put like a fake temperature value up here. So you can imagine you might have, like a temperature sensor. And for this one, I don't know, let's put like, how about 102.78. That'd be a little bit hot temperature. We'll put an F after that, 4 degrees Fahrenheit. And so for this, let's put this back at position 0. So this should be the top line, and then below it we have humidity. And then let's see if we can get one more line of text on here. So let's try, I don't know, how about hello world again. And let's see if we can get this starting at Y position 20. So it looks like we might be able to get 3 lines of text on here. So that'd be kind of cool. And let's do OLED.show. And yeah, check that out. So it might be a little hard to read, but you can see there's temperature, humidity, and then hello world. So that's a solid 3 lines of text on here. And it looks like you can get about, I don't know, let's see, humidity plus 57.2, somewhere around like 15 or so characters across. So a decent amount of text that you can display on this little OLED, just using MicroPython here. So this is cool. This is great for like a little monitoring project, like something that I wanted to build. Like I mentioned, I was hiking yesterday over the weekend. It would be fun to have like an altimeter, tiny little altimeter that you could take with you, because if you haven't looked, you can get an altimeter watch, but those things are not cheap. They're multiple hundreds of dollars. So you can get cheap little things like the BME 280, I believe, is like a pressure sensor. And if you know pressure, you can kind of estimate altitude with that. So I've been thinking about a fun little project would be taking one of these little feathers and getting a little barometric pressure sensor and using it as an altimeter. So as you're hiking up a mountain, you can see like, oh, I'm at 7,000 feet right now, and maybe know kind of where to go from there. So okay, so I think this is pretty much all that I wanted to show. There's one other command that's kind of nice. There's an invert command. And so with this, you pass it a true or false. So if I pass it true, this is going to invert the display. Oops, there we go, true. And this one you actually don't have to call show with. It's using a different thing, but it's a little hard to read. It looks like the camera's kind of blowing it out, but now it's a white background with black text on it. So that's kind of cool. It's simple and easy to do, and you can do false to put this back into the default state where it's black background with white text, which is probably what you want for these OLEDs. Because when it has to turn on pixels, that's taking a little bit more power for this. And that's okay, so that's all there really is to using this SSD1306 OLED display with the ESP8266 MicroPython. Really, the unfortunate thing is you have to compile it into a custom MicroPython firmware, but I showed how to do that. You just have to copy a file and build it, and I've got guides on how to do all that stuff. And then once you have it, you just have to create that I2C interface if you're using the Featherwing like this, or if you're using a breakout with I2C interface. If you're using the SPI interface, you just need to change, instead of using this SSD1306 I2C class, you're going to need to use the SPI class right here. And so this needs to take in a SPI device instance, and I did a whole guide on using SPI with MicroPython, so check that out for more details. And then it needs to take in, when you're using the SPI interface, there are usually extra pins beyond just the SPI protocol. So there's like a data or command pin, and that's what this DC is. There's a reset pin and a chip select pin. So these are pin objects that you'll need to use. So maybe in a future video, I might come back and try one of these OLED breakouts using the SPI interface. But if you just want an OLED that works, use the Featherwing like this. It's literally plug it in and use the class just like I showed in this video here. And then once you have that set up, it's just real simple. You create an instance of that object and then use the pixel command, the show command, the fill command to manipulate the frame buffer and put data on the display. So it's pretty straightforward and simple. And you saw, like, I did this all using the REPL in MicroPython. So I can do this all interactively, but you could put this into a script, you could put this into your main.py file, like I've mentioned in the guides, and build a little device that, uses your OLED and displays interesting data with this. And, maybe you could build like an Internet of Things device where using the network stuff on the ESP8266, talk to a web service, maybe, get the current state of like Twitter or something like that, and display it on your OLED, or, do fun stuff with it. So lots of cool potential with this. And hopefully going forward, we'll do a few more videos on interesting hardware you can use with MicroPython and the ESP8266. And like I said, I hope to do a guide on this, but I've got a big backlog of stuff that we're working through. And I do want to mention, we have other drivers for some of the Featherwings. So if you go to the Adafruit GitHub repository, and if you search for MicroPython Dash, this will show all of these MicroPython Adafruit repositories that we have here. So like here's the PCA 9685. And this is distributed basically as .py files. And, stay tuned. This is more for advanced users. But in the future, we hope to distribute some of these in a little bit easier to consume format. But this is just like that SSD1306 .py file. Actually, the same person who created that helped create some of these drivers. So, props to them for doing that. But basically, this is code that lets you use, like the PCA 9685. This is the servo or LED PWM driver. So if I search for Adafruit servo Featherwing, then you'll see this device. And here we go. So this is a handy little board, and so I hope to do some more videos on this in the future. But this is great. This is a little Featherwing you can plug in, and you connect servos to this, and it can drive those servos, using really nice, precise PWM pulse width modulation output. Because if you look back, I did actually a video on analog input and output with MicroPython. On the ESP8266, you can do pulse width modulation, but there's only so many pins that you can have for that, and it takes some resources and like. I think the not the duty cycle, but the frequency kind of has to be fixed between all of them. And so the limitations, using these little add-on wings like this it's really nice, especially for servos, because it can have a dedicated power input to drive these servos, because servos can pull a lot of power. You don't want to try and pull this over a USB cable. So it makes it really simple. So again, look for future videos. I'm going to hopefully explore how to use some of these things in the future. But I just wanted to give a hint that some of this code is out there. And again, this is more for advanced users, because you're going to have to take this code and, just like I showed here, put it into that scripts directory, build a custom MicroPython firmware that includes this, and then there's not much documentation on this yet, so you're gonna have to look at source code and see, okay, for this there's a frequency function, there's a PWM function, duty cycle function, so stay tuned. I'm gonna hopefully document a lot more of this in the future, but if you're really curious and itching to get started with some of this stuff, this is where you can find it. So again, check out the MicroPython dash. And so there's pretty much every feather wing, as far as I know so far. We've got a basic driver set up for this that you can check out. So, the Max 7219, this is like an LED matrix driver. ADS 1015, this is a nice little analog to digital converter. The Charlie Plex feather wing, that's a really cool display. I've got one here actually that I haven't soldered up. So this is kind of neat. You get this little matrix of LEDs. And this one's cool. Like, this is great. So you can see this has a whole bunch of LEDs on it. Cool for like scrolling messages and stuff. This will make a fun project in the future for this. So lots of fun stuff here. Keep your eyes peeled. We're going to have a lot more info on this in the future. So, okay, so that's it. I'm going to wrap up the stream. If there are questions, throw them into the chat, and we'll see how to get, or we'll see if we can answer those. Oh, someone is there a scrolling text command in MicroPython? Oh, good question. Actually, that reminds me, there is a scroll command on this SSD1306 that I haven't actually used. So the scroll command, let's try it out. I haven't used this yet. Okay, so I've got my text on here. So it looks like this takes a dx and dy. That's probably like a delta, like how far to move in the x and how far to move in the y position. So let's try it out. Let's do OLED.scroll, and let's try the x position, so left, right. And I'm going to guess that if I move it, if I give a positive delta, it's going to move it to the right. And if I give it a negative delta, it hopefully moves it to the left. So let's try a negative 32. So this should hopefully move my text over by 32 pixels. And the Y position, I'm not going to move that at all. I'll just give it a 0 here. So I do that, and then I have to do the display, the show command again. So I do that, and yeah, it looks like it just scrolled it over. So you can see there's like the temperature here, and it's a little interesting. So I scrolled it over, but I notice it didn't clear out the other side of the, it moved it over, but it looks like I can still see some of the old text right there. So that's interesting. That almost feels like a bug to me. I don't know, maybe it's undefined what the behavior should be when it scrolls. So there is a scroll command built in though if you want to scroll stuff, but it looks like you might need to do a little bit of work. Like what you could do is you could say, OLED.fill 0, so like clear the screen, and then show your text again. So let's see if I've still got some of this stuff in here. So like, yeah, we'll do text here, and let's see, we'll put that in, and then well, let's see, this may or may not work. I don't think it'll work, so let's try that scroll again, and maybe let's try like negative 64 for this, and then 0 also. So we're not going to scroll in the Y position. Now let's do a show and see what happens here. So yes, right, it's you still see some of that old text there. So I don't know, there is a scroll command, but maybe there's some bugs. I don't know, arguably maybe that's not a bug, but it feels like a bug to me that, maybe this should take in some parameter that says what should you do with those pixels that you scrolled off. Do you want to like set them to a certain color or something like that for it? So but yeah, so someone's saying, could you do that in a for loop? Yeah, you totally could, like do some basic animation. If you're animating stuff, the general thing that you probably want to do, have a loop, clear the screen, write everything out, and then show the contents of the screen, and then go back to the start of your loop. So like at the start of your loop, you clear the screen, and then like do some computations. Like if you're scrolling something, figure out like how fast is it moving, and then where you want to set, the point that you want to create that on the screen, like what pixel, and then put it at that point, display it, and then when you start over, just clear the whole screen. Like it's really hard if you try and like remember what you had previously on the screen and then only draw the pixels that changed. That's actually a common technique that way back in the day you'd have to do. Dirty rectangles, I think, is kind of what you call it sometimes, where you figure out like what are the parts of the screen that changed and only modify those parts of the screen. But there's a lot of complexity to that, so it's usually easiest to just clear the screen, draw everything, and then start over with each iteration of the loop for that. So let's see. So let's see if there are other questions in here. So let's see. Can we encode a video for a Raspberry Pi and stream on this circuit? If it can show the pixel, then we can stream too. Oh, so I think you're asking, could you show like a video on this display? That is an interesting question. So you could, but it's gonna be really slow, unfortunately. So this display uses the I2C interface. I2C only runs at 400 kilohertz in the best case, and this is a software implementation, so it's like bit banging. So you're not gonna get fast update rates with this. You know, I would bet anything more than a couple times a second would really be pushing how fast it can update this display. Maybe you can do a little faster than that, but certainly not like 24 times or 30 times a second for this. And then again, like this board is not going to have the memory or the processing power to decode video. So you'd have to set something up like have your Raspberry Pi streaming out, like maybe decoding the video and scaling it down and then telling this display like, okay, these are the pixels to turn on or turn off. You maybe have to set up some kind of like little serial command that you're using for that. So the short answer, no, you're not going to display video easily on this. The long answer is, yeah, you could do it. It could be an interesting hack. It could be kind of fun to display stuff. But I think a better use case for this is like a small interface. So you're displaying stuff, sensor readings, things like that for this. And this wing, I didn't mention it, but there are 3 buttons on here on the left. And these are actually just hooked up to some of the GPIO pins on this board. And so if I remember correctly, if you go to the product page, so this shows on the ESP8266 Feather, buttons A, B, and C connect to the GPIO pin 0, 16, and 2. So actually, let me just show how to use those real fast. So I did a whole guide on using digital I/O with MicroPython, and so check that guide out. But I'll show here just a quick little version of this. I've already imported the machine module. I needed that for the I2C interface, so you have to import that. And then let's say button A, so we'll create an instance of the machine.pin class. And so for button A, that should be pin 0 right here. So let's say pin 0, which I can't remember if that's used by the serial port, but we'll try it out. We'll see what happens here for this. And then let's see, I need to tell it if it's an input, so machine.pin.in. And then I probably want to set a pull-up resistor on this because then that way I can read this pin, and if it's not pressed, then it's going to be at a high logic level, and if it is pressed, it should fall down to a low logic level. So I want to say machine.pin.pull_up. And some of the pins on the ESP8266 have pull-up resistors or pull-down resistors in some cases connected to them. So I don't remember offhand with GPIO 0 if this is a good one or not, but let's try it. So then I create this button instance, and the value function returns the current value. So value of 1 means that it's at a high logic level, and because I set a pull-up resistor, this basically should tell me that the button is not being pressed. Now if I press button A, so I'm going to hold that down and call the value function, hey, look at that, I get a value 0. So if I release it, I get a value 1. And if I press it, I get a value of 0 like that. So that's how you could read button button A on this. And then same thing should be possible for the other buttons. So let's try like pin number 16 for button B. And so for this, I'll just say change the pin number. And so, oh, interesting. So I'm running into a little issue here where, like I mentioned, some of the pins on the ESP8266 do or don't support pull-up resistors. In this case, it might be a little hard to use this one. You could set up an external pull-up resistor for this one. Like if I don't set up this pull-up resistor, then it's going to be a little bit weird. I can create this as an input, but whenever I call button B.value, it may or may not be at a high or low level. Like if I hold this thing down, it seems to work right now, but because there's no pull-up, I don't know for sure. But that GPIO pin might have a pull-up resistor connected to it. Check the ESP8266 documentation for MicroPython. It mentions which pins have pull-up resistors and which ones don't for it. But that's the basics. That's how you could read these buttons. And pin C I won't show, but you just use GPIO number 2, like it mentions here for that. So that's how you can use the buttons there. So let's see. Oh, someone was mentioning they're trying to make a module to use fonts with the Charlie Plex display, but running into memory limits. Yeah, so that's one of the tough things with MicroPython, unfortunately, is that all of your Python source code, if you're just using raw Python source code, it's going to actually have to load that source code into memory, and then in some cases you actually have like 2 copies of it in memory, so it's not the most efficient thing in the world. And on these little boards, the ESP only has 96 kilobytes of memory, and some of these drivers can get pretty complex. So if your driver has like 10 kilobytes of Python source code, that's a lot of memory that you'll take up very quickly. And like a font, for example, you're going to have probably like 128, maybe 64 characters or something like that. And that's a matrix of pixels, so that's going to be a couple kilobytes of memory for that. So one suggestion, try to freeze as many modules into your MicroPython firmware. I did a video and a guide on this about how to freeze modules into the firmware. When you freeze a module, that puts it into the flash memory of the chip instead of the RAM, and so that will cut down some of the usage a little bit for that. And then, you know, if that still causes problems, you probably have to look at like, how can you store your data file in Flash and then just read out chunks of it that you care about? So that maybe gets a little more complex. But as a first thing, try to freeze as many modules. Like, you know, the less .py files you have and that you import, the lower your memory usage should be, and the better luck you'll have with it in this case. And then maybe ultimately sometimes you just might run into too many limitations. Like the microbit only has around 4 kilobytes of memory, so there's not much you can do with 4K. So you know, you might have to like move up to a slightly bigger board to deal with some of those limitations. So cool. I think that was about it. So, oh, can we show graphs with matplotlib? That would be kind of cool, matplotlib. Again, like you're not going to run matplotlib, even though this is Python. As far as I know, no one has ported matplotlib to MicroPython, but that would be a heck of a cool project to do that. But what you would probably want to do is write like a little firmware that takes commands over the serial port, you know, like a turn on this pixel or turn off that pixel, and then have some code that runs like on your computer that's actually running the real matplotlib and telling this display, okay, you know, display this or display that kind of graph with that. So that'd be a cool thing to do. So, okay, cool. I think that was it. So I'm going to wrap up the stream. I'll switch back to the main view right here. And let's see, and hopefully sometimes the video glitches out on this view. I keep meaning to set up the latest version of Wirecast, so one of these days I'll do it. But anyways, thanks a lot for watching. So this was a stream on how to use the SSD1306 OLED display with the ESP8266 MicroPython firmware. A lot of acronyms there, but basically how to use this little OLED with MicroPython on the ESP8266. And so I showed how you have to build a custom firmware that includes this driver file, and then just with a few commands you can create an instance of this object and then start displaying things on the little OLED display there. So check out youtube.com/Adafruit. You can see this video and all kinds of other fun project videos. Check out twitch.tv/Adafruit. That's where I like to stream these things live. And then I like to do a couple streams a week, so I do one on Mondays usually, although I'm thinking I might move this to like a Tuesday stream just because sometimes it's hard to get a lot of things. I want to get back into a mode of having a guide and a video at the same time kind of published, and so it's hard to do that on a Monday. But at least a couple times a week I'm trying to get back into that kind of rhythm of things. So I had a whole bunch of fun events in the last few weeks that are, you know, finally back to getting some work done now. Okay, so yeah, this is Tony from Adafruit, so thanks a lot for watching. Like, comment, subscribe, let us know that you like these videos, you get good stuff from them, and we'll keep doing them. So thanks a lot for watching. I'll see you guys later.